Solving a system of equations by substitution. We're going to be focusing on linear systems. In the first system, we have y equals 3x and x plus y equals negative 32. When solving a system using substitution, you are going to substitute your value for a variable. So for the first equation, we know that y equals 3x. So wherever we see y in the second equation, we're going to plug in a 3x. So x plus 3x equals negative 32. Collect like terms. So 4x equals negative 32. Solve for x, divide both sides by 4, and x equals negative 8. Now remember, we are not finished. The solution to a system is the point or points that is true for both equations. We need a point, an x and a y. Right now we just have the x. So now to figure out the y part of the ordered pair, we would plug in x into either one of these equations. I'm going to use y equals 3x. So y equals 3 times negative 8. So y is negative 24. Again, you're still not done. You need to write the solution as an ordered pair. So negative 8, negative 24. Y equals 2x plus 7, and y equals x minus 1. Now in this case, both equations have been solved for y, so it doesn't matter which one you substitute into the other equation. Y equals 2x plus 7. So wherever I see a y in the second equation, I'm going to write 2x plus 7. So now I have variables on both sides. Move the variable that's smaller. So subtract x on both sides. X plus 7 equals negative 1. Subtract 7 on both sides. X equals negative 8. So again, I need the x and the y coordinates. So plug in negative 8 to either one of these equations. This time I think the second equation is a little easier to use. So y equals negative 8 minus 1. Y is negative 9. So your solution is negative 8, negative 9. Keep in mind for both of these examples, we had one ordered pair as the solution. So the graph of these equations would be two intersecting lines at these given points. Now in both of these examples, the equations were solved for y that we were substituting. But it doesn't matter whether you're solving it for y or x. So in the next example, x equals negative 2y plus 4, and 3.5x plus 7y equals 14. Again, x is negative 2y plus 4. So wherever we see x in the second equation, we're going to plug in negative 2y plus 4. So this is 3.5 times negative 2y plus 4 plus 7y equals 14. Distribute the 3.5. So negative 7y plus 14 plus 7y equals 14. Collect like terms. Negative 7y and 7y, they cancel out, and you're left with 14. 14 equals 14. That's a true statement. That tells us then that any value we plug in for x or y, we're going to have a true statement. So this is many solutions. If we were to graph these two equations, we would have the same line. They would be one line on top of the other. Y equals 3x minus 11, and y minus 3x equals negative 13. Okay, the first equation is solved for y, so wherever I see y in the second equation, plug in. So 3x minus 11 minus 3x equals negative 13. Collect like terms. 3x and negative 3x. Again, these cancel each other out, and you're left with negative 11 equals negative 13. This time, this is not a true statement. So that tells us there are no numbers that we can plug in for x and y that would make both equations true. So this has no solutions. So the graph of these two equations would be parallel lines. In our last system, 2x minus y equals negative 4, and 2x minus 2y equals negative 10. Now what's different about this system than any of the ones that we have done so far is that neither of them are solved for either x or y. So what you want to look for is if one of the variables has a coefficient of 1 or negative 1. And in this case, the y in the first equation has a coefficient of negative 1. So what we want to do is make it so that this equation is y equals. So subtract 2x on both sides. Negative y equals negative 2x minus 4. Divide by negative 1 on both sides. Divide everything on the right by negative 1. So y equals 2x plus 4. Now that we have what y equals, substitute that in to the second equation. 2x minus 2 in parentheses 2x plus 4 equals negative 10. Distribute this negative 2. 2x minus 4x minus 8 equals negative 10. Collect like terms. Negative 2x minus 8 equals negative 10. So we need to solve for x. Add 8 to both sides. Negative 2x equals negative 2. Divide both sides by negative 2. And x is 1. But again, we're not done. We need to get the x and y coordinate for our ordered pair. We have three choices now of where we can plug in x equals 1. One of the two original equations or what we solved y for. I'm going to use that equation. So y equals 2 times 1 plus 4. Y equals 2 plus 4. Y is 6. So our solution is 1, 6. Intersecting lines at the point 1, 6. So to summarize, to solve a system of equations using substitution, you want to use this method if one or both equations is in the form y equals or x equals. Or you would use this method if x or y has a coefficient of 1, and then you would solve the equation for that variable and then use that for substitution.